was the future programming .NET at Microsoft and the future of C++. So how are you dealing with what the restraints you have, the constraints you have in the C++?
Well, the constraint of C++ to begin with is that it's hugely successful and popular. That is a constraint because it limits the amount of leeway you have, even as we do our work in the standards committee, as internationally all the different companies and participants there, because once you're popular, people are using your stuff and you can't just break them. So everything that you've done and shipped, you live with. And that's true of the ISO C++ standard, and it's true of the product. And largely that's a very good legacy to have. I mean, it's a good problem to have lots of customers, but also it's good to have a powerful and flexible language that people are using to get real work done, and one that's known for efficiency too. So when you think of those two things, that's really what makes C++ a systems programming language. So sometimes people think, well, that's great. In the future, we'll just be doing device drivers in C++. And that's not really realistic because it's also a very high-level language with great abstractions and templates in OO and in other ways. And when you think about a systems programming language that lets you get close to the machine, that applies just as well to .NET to get close to the virtual machine. So, for example, in .NET, we are and would be the systems programming language for .NET in that we expose more of the .NET features than any other language does. So, for example, one of the cool new features in .NET 2.0 is generics, right? You get generic types. And C++ has had those already for some time in the form of templates. They're compile time, whereas .NET generics are runtime and cross-language. Without drilling too far deep into that, just avoid both of the mistakes of thinking one is better than the other. Neither is inherently better. They're different, complementary. One of the cool things is when you have them both in the same language, you can get a lot done. But in terms of language support, and supporting what the CLR supports. If you want to use generics, you can use them in VB, you can use them in C# and in C++. But C++ actually exposes more of the underlying features of generics in the CLR that you can actually do in the CLR than other languages choose to. And that's just a design choice because by default, C++'s philosophy is trust the programmer, give them the most flexibility of the tools to express what they need to express. And other languages like to keep things a bit simpler and more constrained. So we surface more of the ability that's in the CLR.
Interesting. That's a good point. So what are some of the, now when the first version of C++.NET, or I'm not sure exactly what we called it, there was a sort of a large number of C++ programmers that really didn't like the syntax for writing against the managed heap, etc. What changes have you made this time?
Right, so we had to go back and fix the language. So the extensions as they were first surfaced, they were well-intentioned. For instance, double underscore in front of everything because that's one of the sanctioned ways to provide extensions that don't trump on existing, ISO-conforming programs. And it turns out that all the programmers said we're getting carpal tunnel syndrome, holding down the shift key and doing this underscore thing all the time. It's just, we hate it, it's ugly, and there were other problems with it, just in the way it surfaced things. It wasn't as clean a language design as it should be. And so for Whidbey, we went back and looked at it and said, okay, from the ground up, let's do this. And now we're taking all the lessons that we've learned from that experience and bringing in folks like Bjarne at EDG and Dinkenware and Plum Hall, have them collaborate with us in advance as we're doing this design to get their feedback on what works and what doesn't. And their feedback has been very, very valuable in making it as seamless and clean as it is. And then ship that.
And these people are just...
Oh, Bjarne Struster, it's C++ is his baby. It always will be. He's the inventor of C++. Edison Design Group, one of the premier C++ compiler vendors, implementers in the world. They basically do the C++ language, and then they sell to folks like Intel and HP and others in Borland who build compilers, put the back-end stuff and the code generation in the compiler. And then Dinkenware, who does the C++ standard library. They're one of the biggest vendors of that in the world. Plum Hall of C++ test suites. And all these guys are the key players in the ISO C++ committee and have long experience with C++. And so having said that, not just from specifying it and also implementing it, these are the guys who know well what works and what doesn't, and we're able to provide really good feedback to us to help us to get it clean.
Fantastic, and that's a great point because a lot of people have a misconception that that we do things in a black box, that we decided C++ would be this way. We decided that. This is nice to hear that we're working with very, very high-level people in the community the inventor of the language, for example. That's a great point.
So that's one mistake we fixed, right? Because we didn't always do that.
Okay, but we are now.
That's right.
So fantastic.
Yeah.
Now, what other changes have there been made to the language in the compiler, for example? Are there more checks, more security checks built in? Things like this?
Yeah, you can never have enough security checks, can you?
Yeah.
Yeah, so a lot of work's been done in our Everett and our Whidbey, our compiler, which is currently in beta. So Visual C++ 2005, I think, is the official name.
Okay.
And so that's going to be in people's hands real soon. And you can, by the way, get that free copies available for download from the website. We're doing that new in this release. So free betas, and maybe when we ship that.
Which website? MSDN?
From our Visual C website. Yeah.
Okay.
We can put a link in here somewhere.
Totally.
And so get it, play around with it. Beta 1, Beta 2 will be coming out real soon. And so that gives you some of the look at what we're doing in the new language for .NET, but also stuff like security, where we're doing more with the /GS switch to do things for checking buffer overruns and stack-based buffers, things like that. And there's also a cool project that we've been working on, which deals with securing stuff like sprintf and strcpy, which is the C standard library. And there's a ways more we could go yet with that. But we've also already progressed things to the point where we can say, here's a securer C standard library, and which is actually being standardized. We submitted that work for standardization, and that's actually now in balloting and is hopefully going to become a technical report out of the C Standards Committee over the next year or two. So that's promising. Other people have seen the value of that, and we want to do what we can to help make our platform more secure and our customers more secure. But security is good for everybody, and the more that we can help people become more secure, the less problems we're all going to have.
Absolutely. And, C++ is certainly the language that will get the most visibility. Not that you want it, for things like buffer overruns.
That's such a polite way of saying we have so much further to go.
Yeah.
And, the reality, that is the reality.
Yeah.
And people are using C++ because of its power and efficiency, the flexibility and the performance, in spite of the fact that it's a complicated language,
yes.
and in spite of the fact that there are insecure parts to it. Most of the language is perfectly secure, but because it lets you get down to the metal and it has the philosophy inherited from C of trust the programmer, we trust our customers. There are some times when really the customer doesn't want to be trusted and wants to be checked, and so we're going to keep on doing work to make things more secure. Most of the work that developers have seen, customers of our tools have seen, has been on the managed side, where we have languages that are secure, runtime that is secure, verifiability checks and stuff like that. And so over time, expect to see more of the stuff that we're doing on the native side for detecting stack-based overruns and making the C standard library secure. That's the tip of the iceberg, and we hope to go much, much further with that, because we need to solve the whole security problem. And C++ is not going away anytime soon. .NET is not going away anytime soon. And you need both of those. In a recent talk at OOPSLA, I compared that to, if you look at C++, it's like the steel and the concrete of software development. If you're going to build tall buildings, or you're going to build buildings that span great distances, like arches or dome stadiums, that you really do want to be using concrete and steel. I mean, if you're working on the 84th floor of a high-rise, we don't have any that high here on campus, fortunately, but even these ones here on the second floor, I'm glad there's concrete underneath my feet. I would not feel as safe up on the 84th floor if it was, wood, even if it was mahogany. That's all there was. But on the other hand, we do want the services of garbage collection and of a runtime and of verifiability. Those are really important things, and you can't ignore those either. With just the concrete and steel, you could build a 100-story building, but if you don't have the services like the HVAC that bring the right pressure and the right temperature to all those things, an elevator system that can reach those floors so you don't have to walk up the stairs like you do with manual memory management sometimes. So GC is like that. You certainly want the water system so that your pressure is great enough so the guy at the top can get water out of his faucet, but the guy at the bottom doesn't turn the faucet and get blasted against the wall by the water stream. So you need those kinds of services as well as concrete and steel, and that's why you need GC and verifiability, and you need concrete languages like C++. And it's not really an either or. You really want them both, and you want them to work well together.
Absolutely. Now that brings up a good point in the sense that I'm assuming you do a lot of work with the CLR team. So
They've
that
seen me a few times.
they've seen you a few times, so that you can get what you need out of what their environment. For example, you just talked about wanting to have strict control over memory at some point, and at some point being fine with letting the GC handle it. But today, regardless of what language I use, when I'm writing managed code, I can't really know when an object will no longer exist. Correct? So my question to you is, are you working with them on deterministic finalization, or trying to come up with some solution that will work for C++ in their world, in this area?
That's actually a very perceptive question. I'm not saying that you look unperceptive. You don't. But that's a perceptive question, because a lot of people assume that virtual machine environments, including Java and .NET, are already fully type safe, and they are mostly. But for example, right now, all virtual machine environments I know of, they don't do destructors like C++ does. But they realized after the fact they really needed something like it, and so they invented the dispose pattern. And in reality, dispose is the destructor. Let's get over it and admit that's really what it is.
Okay.
But the problem is there are many dispose patterns, because we've regressed something that's actually supported as a language feature into a coding feature where you have to pay attention and get it right. Come on, you can do it. And so really you want something better. And so what the current platforms are like, and where they could make further progress, is in being better about distinguishing between memory lifetime and object lifetime. Because right now all of these platforms have holes on the edges where before construction or after dispose, you can still have an object reference to an object, but it's not really that well defined what happens if you try to use it. If you try to use an object after it's been finalized or after it's been disposed.
Yeah.
Incidentally, the CLR world plays well into concurrency, because there really is no such thing as a single-threaded .NET program. There really isn't. And the reason is, even if you don't introduce any threads of your own, and even if the frameworks you're using don't introduce any threads of their own, your finalizers will be running on a separate thread. So there is really no such thing as a single-threaded program. And if you're writing finalizers, you really need to know about that, because if they're going to try to access members of the object, they could actually be running at the same time in certain situations as just a method call on the same object running on some other thread. It's rare, but it's possible to paint yourself in those corners, and people do it. But many people don't realize just how problematic that is. So concurrency, there's one example of where concurrency really does come up. And it's just going to be less and less of an edge case and more mainstream, that people need to know what's going on and be able to code correctly for.
So where can people find, besides your paper, and I've read that, but more details on concurrency, like patterns and practices? Is that a PAG kind of
There are some books.
reality?
There are some books on it, and they're documenting the state of the art, which
There's
is
some books on it.
Which is what you ought to know. You ought to know the state of the art, which is lock-based programming, and many people learned it in school. And there hasn't been that much more since then. If you're looking at using a particular language like Java or C#, .NET or whatever, know what the features are there. Some of them have different bundles of controllers, surface it in different ways. But the basics haven't changed that much in 30 years in the mainstream, which is kind of interesting. Oh, let's say 20 years, just to be a little more conservative. And so that's what's there now. We need to do better, but don't wait for that. You have to write code today. Learn what's there and learn to use it well. And there are books full of best practices and patterns. Learn about things like state machines. Learn about the problems of using mutexes, how to use locks enough so that you don't forget to use one and then have a race somewhere in your program, but not use them too much, so that suddenly your 10 threads all wait for one single thing and only one makes progress at a time, which basically means you've written a complicated single-threaded system, because only one thread really ever runs at once, and you've lost all your concurrency. So use locks judiciously. That's several chapters in a book right there.
Okay.
But it's chapters worth learning. Learn the patterns, and that's what you can do today. Look forward to better support in the future.
in our tools.
Is there anything you're noticing in college kids coming into Microsoft that they're not getting, or that they learned incorrectly, or that you wish that they had learned in college when they come in here?
This is going to sound awfully self-serving, but I really believe I'm not entirely tainted with my own love of C++ when I say this. C++ is one thing. In particular, one of the things the colleges have noticed recently is that I think it's absolutely great that languages like C# and Java are being used and taught in colleges. This is a good thing. Learn more languages, not fewer. Right? It's always good to learn more languages. In fact, while you're at it, please learn a few like Prolog or APL or Lisp, because it'll make you think in completely different ways, and that's a good thing. But people who are only learning one or two languages that are all of the level of C# and Java are finding that they're missing some basics because they never had to learn how to be close to the metal, how their programs really interact with real machines. It's great to be abstracted away to not worry about the things you don't need to worry about, but sometimes you don't know what you're missing. And sometimes you really should not skip the basics. Even if you learn them and then usually can ignore them, it's important to know them and to know the context of the machines and operating systems you're really working on. So sometimes you can abstract away too much and you can lose a lot. And that's why a lot of college campuses now are taking their first-year CS courses and putting them back to C++, which is an interesting trend over the last 2 years. And I hope that's in addition to other languages as well, because more is better. I mean, everybody should be forced to take at least one course in comparative programming languages. Just spend 2 weeks on each language just to get sort of a flavor for how to think in that language. And then at the end of the term, your brain can unbend, and you can just take 2 weeks off and until your brain untwists into its normal form. But it's good to learn to twist and to think in those ways. But don't miss the fundamentals. Don't miss C++ and C, because you need to know what they have to teach.
In other words, you need to be a master of programming and not just one-sided.
You need to know the effect, the real effect of the code that you write. And if you sit in too much of a sandbox and you never look at the outside world, then you don't know what your context really is, and then surprising stuff can happen to your programs.
Are you going to be at the PDC in September?
Probably.
What should programmers focus on over the next 8 months between now and the PDC? What would you like to see them come to PDC with questions about?
Oh, man.
Or have done some homework. What's the homework for the next 8 months for programmers?
The homework is Whidbey. I mean, we have so much stuff coming out in Whidbey, and not just in C++. It's C# has some really cool features coming out in Whidbey, VB, and .NET with generics. Start using them. If not in your main project, at least start to learn those features so that you can then know where to apply them in your day project. And then when you come to PDC, give us your feedback. Before that, go on the newsgroups. Let us know what was done well, thanks. But even more importantly, it's nice to hear good stuff. I learn the most though from finding out what doesn't work well. And so what can we do better? What can we fix? What problems are you trying to solve right now that are hard? And that you tear your head out, your hair out of your head on Saturday evening when you wish you were out with the guys or with your family if you're married. And a few people here, we're getting to be more of a married group here, that includes me. And you're tearing your hair out saying, why am I still here? This should have been done on Tuesday and I'm still sitting here on a Saturday night. This just has got to be easier. Make those wish lists and tell us what they are. It may be that we won't have an answer, or one that it may not be. There may be so many people asking for things that we can ship 10 of them and 20 we can't. But at least let us know, and then we'll be able to listen. That's how we listen to the customer, know what problems you're trying to solve. We try to do that on our own anyway, but it never hurts to tell us. It's always a good thing because there's always stuff you miss.
And you guys are hooked into the product feedback center on MSDN.
Yeah.
All the product feeds.
So that's where to go.
I bet you see some pretty interesting software in your position here in Microsoft and your industry. What's the coolest thing you've seen in the past few months?
Oh, define interesting.
Everything from Flight Simulator to Excel, right?
Yeah, right. I mean, there's so much cool stuff going on in all sorts of different ways. I mean, you can talk about the way that the games, real-time games, are just coming along in a way that just seemed magical 10 years ago, that probably we never thought we'd see in 20 years, and we're there today. And some of the stuff they're doing is just awesomely great. Then, if going from there down to the nitty-gritty coding level, some of the lock-free programming that I just said, was for geniuses only, I try never to do that stuff in my day job because I don't know if I'll get it right. It's really finicky. But it's still a lot of fun to play around with. And so some of the lock-free data structures that people have created, where you can create, say, a hash table and have it be efficient, but never take a lock, even if 100 threads are beating on it and reading and writing from it at the same time, and there's never a lock. That stuff is extremely subtle. It will bend your mind in a completely different way than I just said about other programming languages. but it's just cool to see how did they do that. You know, you dig into it, and I spent the winter break reading lots and lots of research papers about concurrency, everything from transactional memory to lock-free programming to higher level stuff in polyphonic C#, C omega, and those projects, and it's just a mind-bending blast to just sit and learn new things. So people should do that, by the way. You know, I remember what it was like to be just writing software. You're on a product team, and there always seems to be more features than you can possibly ship, and you never have time to learn or to read or go to a course. Even if you can't get away to a course once a year, read the magazines. Go make time every week to say, okay, at least just a half an hour a week I'm going to read something and learn about something new. And every so often, make sure it includes something that is not directly related to what you're doing. Find out what else is going on out there. It'll make you more valuable to the team that you're already working in, even if they never use that technology. And it's all part of just being able to see things from several different ways instead of just learning one thing and never growing beyond that. We don't want to be like those people in the Middle Ages who would grow up in one village and spend their whole lives and die at the age of 60 without ever having gone 5 miles or more from the place they were born. Like you don't want to be like that in software. You want to go out and see what's there.
You probably have a pretty unique view of Longhorn and the next products that Microsoft's coming out with too, because you're the language that all of those things are built with, right?
Guilty.
Guilty.
Mm-hmm.
And
I think it's a good thing. It's
you just got a new compiler too, right? For right, the Phoenix compiler. Is that a new
That's
compiler?
the research.
There's research
Extensible
going on right
compiler.
now in a next generation compiler platform.
Okay.
Yeah, which is intended to be for multiple languages. It's part of our Visual C++ product team, but they're really distinct, although they're under our umbrella. They were away on their own, now they're back again, and they are doing some really, really cool stuff that hopefully will bear fruit over the coming years. And the folks in academia have already had a chance to see a lot of that stuff, and it's really interesting where they might be able to take that over the next few years. So that, you know, if to the extent that is wildly successful, that will no doubt have an impact on compiler technology you see coming out of the developer division over the next 5 to 10 years.
How do you work with the other teams here at Microsoft? Do they come to you and say, you know, the next version of Office or the next version of Windows needs this? You know,
Well, mostly we just show up in each other's offices and throw Nerf guns at each other.
Right.
So yeah, if you need something to get done, people just come up with a request. I have never worked in such a free-form culture here. I probably wasted my first 6 months trying to find out who reports to whom, because there's almost no direct reporting relationship that really matters. Like program managers, PMs, who are sort of the glue between the developers and testers and management to get everything done. Nobody reports to them, and yet they have all the accountability for getting everything done. I've never worked in an organization quite as, how can I put it, democratic to a fault as this one, where everybody has a voice, and there's you have to learn to work in that environment. There's some overhead in learning how to work in that environment, but there's also a really big payoff because everybody gets heard, everything's flexible, and you have a lot of flexibility to do stuff that you wouldn't have in a more strict, organized or hierarchical organization. So it was a bit of a learning curve for me when I got here. You mean nobody reports to you, but you're running the project, you know? But that's often the way it is.